Alright, 13A says, a scientist used 62 grams of carbon for an experiment. He performed the same experiment 3 times. Which equation shows how to use the distributive property to find the total number of grams of carbon he used for the experiment? So we are wanting to find the total number of grams of carbon he used for the experiment, all 3. And it says he used 6.2 grams of carbon for an experiment. What does "an" mean? For how many? One. For an experiment means 1 experiment. So for every 1, he used how much? 6.2 grams. It says he performed the same experiment 3 times. Okay, so here's what I want you to do. Distributive property says, I'm going to break up the values of what I have. So, I'm doing 3 times, then I look at my number 6.2, right? This is what I would have in the traditional algorithm, the traditional numerical sentence. Okay? In this case, I'm going to take my 3 times 6 and then I'm going to take 3 times 0.2, not just a 2, because that is not just a 2, is it? No. So this says what I'm going to do is 3 times 6 plus 3 times 0.2. So first I do this, then I do this. I broke it down into the values. I'm taking my number and I'm multiplying the first whole number, then I'm multiplying the decimal portion of that number. I'm breaking it up. I've distributed my 3 to multiply it times 6. I've distributed my 3 to multiply it times 0.2. Which one looks like this? Very good. D. Some of you might want to pick A. Be very careful with that, because here's what this is saying. That you did 3 experiments and you used 6.2 grams of carbon in that experiment. But in this case, it's saying that he did the experiment 6 times. He did not do the experiment 6 times, did he?
No.
No. He didn't take that 3 and do it twice. Who is it that says they put A? You did. Okay. Well, do you have it correct? No, you don't. So look at why you missed it, understand why you missed it, and then go ahead and change it. So, anybody confused as to how we distribute our numbers? Kind of get it? Okay, we're going to do another one, 13B. It says, Francisco put 4 quarters in an envelope. He knew that the mass of 1 quarter was 5.7 grams. Which equation, so we're looking for an equation, shows how to use the distributive property to find the combined mass of the 4 quarters. So basically what we're looking for is the combined mass of the 4 quarters, and we're looking for an equation that shows that. Okay, so first off, we know that we have 4 quarters. One of the quarters, that's another way of saying each quarter, right? One of the quarters weighed 5.7 grams. So, I'm going to take 4, and then I'm going to put a parentheses, and I'm going to put 5.7, and then close that parentheses. I want you to understand that this means 4 times 5.7. That's what that means. This also means 4 times 5.7. Because the parentheses mean multiplication. The dot means multiplication. Everybody see that? Yes. Everybody remember that from learning it towards the beginning of the year? Yes? I know the new one might have been the parentheses that maybe threw some of you off. No. Where? Marla, this is a decimal point, Marla. Each one weighs 5.7 grams. Nope. That's a decimal. 5 7/10 of grams. 5 7/10 of a gram. Okay. Basically what this is saying is I'm multiplying my 4 times my 5, right? And then I'm multiplying my 4 times my 0.7. I underlined this one time, and then I underlined it twice, because 4 times 5, one time goes first, and then 4, and bring it over to the 7 times 0.7 is second. So right here on the side, I want you to write the steps in order. First we do the 4 times 5, and then we do the 4 times 0.7. And you can have the 0.7. Once you get those, you add them up. Once you get those, you add them up. See if you can get the correct answer. Alright, for your answer choices, you have F, G, H, and J. And what we're going to do first is we're going to solve this to get our answer. So if I did the 4 times 5, that gave me 20. If I did 4 times 7/10, that would give me 0.28 hundredths. Because 7 times 4 is 28. Make sure that you add the 0 point. So either way, your answer would be 20.28. Now, hold on. Hold on. Let me ask you something. If I did 4 times 5 here, that would give me 20. But here, it's asking me to do 4 times 700. Is that what the question was? Is it 5.07? No. This means that I'm taking 4 times... What? Oh, sorry. Okay. 4 times 5 would be the 20. 4 times 0.07. Well, I determined that my number was 5.7. I was going to take the 4 times 5.7. This is saying that I'm taking 4 times 5.07. This says that I'm doing 4 times 5.07. Because if I distribute this, 4, there's my 4, times 5.07. Is that what we were multiplying though?
No.
No. The answer is correct, but the equation, the expression, is not. Look at letter G. 4 times 5. Yes, right? 4 times 0.7. Yes, right? Equals 22.8.
Yes. Yes.
How did you get that answer?
Because it's 4 times 5 is 20 and 4 times 0.7 equals 2.8.
Let's see. Okay, so if I take 0.7 times 4, 4 times 2, 4 times 0 is 0, the 2, bring in my decimal 1 time. Ah! How many of you did not do that? How many of you just did 7 times 4? And you figured it was 28, like 0.28. Anybody? Because some of you wanted to say this was the answer, right?
I did.
Okay. So, I now have 20 and 2.8.
At the middle, I have
I wanted to see how many of you were going to do the math that said, well, 4 times 0.7 is 28. Because some of you might have said it's 28 and then just put the decimal in front of the 2. Because that's what I had the other group do. Because they did it like this. They did 4 times 5, 20. 4 times 0.7, well, they know that 4 times 7 was 28. So where the 7 was, they just put 0.28. But that's not the case, is it? Because if you use your decimal multiplication correctly, 0.7 times 4 equals 28, yes. But then you have to remember to take the step of count the number of times your decimal goes in, and then do that on the answer. Change that for the product. Everybody understand that? Yes? Okay. You are working on 14A and 14B on your own. 14A and 14B on your own. And while you are doing that, I will go ahead and work on them. Alright, so the total distance around the trail is 2.5 kilometers. The total distance around the trail is 2.5 kilometers. Last week, Mariano rode his bicycle around the trail, so he rode it around the trail 7 times. We're looking for the distributive property equation that shows how to find the total number of kilometers he rode on the trail last week. So I'm going to take my whole number of 7, because that's how many times he rode around. And I know that that's this. So they all have a 7, right? And then I'm going to look at my value of 2.5. So really what I'm saying is 7 times 2.5 like that. Or I can say 7 times 2.5. Or it's the same thing as saying 7 times 2.5. Again, once you get into middle school, you'll start seeing more of this, and possibly this, not necessarily this, because they do use the letter X in algebra for a lot of things. So you won't be seeing the multiplication sign or symbol this way very often anymore. Okay? So they'll give you either the dot or the parentheses. A number with another number inside the parentheses means that you're multiplying. And I like this one for the distributive property because that helps me do this. So first I do the 7 times 2, then I do the 7 times 0.5. So that would mean 7 times 2, and then 7 times 0.5. And you can add the 0 if you want to. Okay? So, this would be 14. 7 times 5 is 35. Bring in my decimal once. And then I add those two because I distributed, but I did not get my final answer until you add them. 14 plus 3, 17.5. Okay, there's only one answer choice that has that, so let's just double check. Did I do the 7 times 2?
Yes.
Yes. Did I do the 7 times 0.5? Yes. Did I get my answer?
Yes.
Your answer is C. Everybody get that correct?
Yes.
Okay. Are you feeling comfortable with the distributive property of multiplication?
Yes.
Okay, so the last question that you had, 14B. A worker at a golf course knows that the tank on a golf cart holds 3.9 gallons of gasoline. If the worker filled the tank on 6 golf carts, that means 3.9 gallons of gasoline in each of the golf carts, which equation shows the distributive property to find the total amount of gasoline he used? So I'm going to take my 6 golf carts and I'm going to multiply it with 3.9 gallons of gas on each one, right? So again, 6 times 3, and then 6 times 0.9. Everybody still seeing how we do this? First I do 6 times 3, and then I do 6 times 0.9. Okay, and we go in order. 6 times 3 is 18. Okay, then I have 6 times 0.9. Well, what is 6 times 9? 54. I have my decimal at the end. I move it in 1. So what's my answer? 5.4. What's 18 plus 5.4? 18, 19, 20, 21, 22, 23. Okay, those of you that did 8 plus 5 is 13, carry the 1, that's fine. 5 and 1, that still doesn't give me, I don't understand why you would do that. Okay, I have the 0.4, 8 plus 5 is 13, carry the 1, 1 plus 1 is 2, 23.4. Okay, you can do that or you can do what I did, 18 plus 5. You're actually taking the whole 18 and adding the 5, which gives you 23. Or you can do the 8 plus 5 is 13, carry the 1, 1 plus 1 is 2, bring it down. Okay, so my answer is 23.4, which only one of them has. So I'm going to just check. Did I do 6 times 3? Yes. Did I do 6 times 9 tenths? Yes. And did I get my correct answer? Your answer was F.